Welcome back, and today we're going to be looking at session 3, which is comparing contextualising fractions and also looking at bar modelling as a potential pictorial representation to help understand and expose the structure of fractions that we could be using. Just a quick reminder, of course, the resources and support here for this training session from West Yorkshire Maths Hub, particularly Sam, the Assistant Maths Hub Lead, and resources also coming from the NCETM. Another quick reminder of the 5 big ideas, remembering to consider these, to think about these, to involve these in every thought of your mathematical teaching: the representation and structure, mathematical thinking, fluency, variation and coherence. If you want to find out a little bit more, there is a separate CPD session all about this, and there's also loads and loads of information out there, so do a little bit of extra research. A final reminder then, throughout the sessions you might see this thinking face pop up. This is an opportunity for you to really think a bit more deeply, a bit more carefully, maybe make some notes, because we will come back to these ideas and reflect on them the next time we have a live session together. Okay, so in previous sessions we started off by looking how fractions fit into the curriculum and what a fraction was. We considered the concept of a fraction, what it could be, what the different elements of a fraction might be. In the last session we focused just on the part-whole relationship and how that was essential and key to the development of the conceptual understanding of fractions. This time we're going to look at comparing and ordering fractions, as well as how we can use bar modelling to help us represent fractions. Okay, so we're going to start with comparing fractions. Why do some children find the concept so difficult? Would you rather have 1/3 or 1/4? Why might that be hard? Well, 4 is bigger than 3, so surely 1/4 should be bigger than 1/3. I'd rather have a quarter, please. Does this lead to difficulties with understanding place value in Key Stage 1, with changing the idea that, oh well, there are 4 1s and 4 1s is bigger than 3 1s, or 4 10s is bigger than 3 10s? Well, why is the 4 denominator not bigger than the 3 denominator? So that could cause some real problems. This needs lots and lots of practical activities. Get some cutting, get some cakes, get some pizzas, get some bits of paper, use different shapes, use squares, circles, triangles, pentagons, all a variety of shapes into unit fractions. Divide them up into unit fractions to help them to visualize and understand the concept of equal parts of a whole and then the relative size of each part. So thinking, well, we've got the same whole, here are 2 circles which are identical. If I cut this one into 3 parts and I cut this one into 4 parts, let's compare them. Yes, finding a third means we divide it into 3 parts. I'm only going to share the cake with 3 people. Finding a quarter means dividing it into 4 parts. I'm going to have to share it with an extra person, with a 4th person. So we're each going to get less cake. If the whole was 12 cupcakes rather than just one object, one whole, then we can easily develop misconceptions here, because now we're thinking, well, I've got 4 cupcakes if I've got a quarter. Well, oh no, finding a third of 12 cakes doesn't mean there are 3 cakes, like a quarter of 12 doesn't mean there are 4 cakes. So it's taking that object and sharing it, physically moving them around between those 3 or 4 people and comparing the amounts you would get. Now, this is an objective that comes higher up school, but beginning to talk about this idea when cutting a square in half and cutting a square into thirds, this starts to build that conceptual understanding much earlier and helps to ensure the understanding of fractions with our pupils. Is this statement true or false? True or false questions, by the way, are great for developing reasoning skills during your input, during your whole class work. They provide an ideal opportunity to address misconceptions just like this one. So since 5 is greater than 2, this means that 1/5 is greater than 1/2. Employ a character, make it your friend, make it you. You could say something, I think that since 5 is greater than 2, this means that 1/5 is greater than 1/2. Or if you're using the Whitewell's maths videos at the moment, it's Tiny the tortoise, or as I've dubbed him in our class, Terry the tiny tortoise. And he always seems to pop up and he has something to say, and he just never seems to quite get it right. And all of my class have really gripped hold of this character now. So use that idea. Get somebody to say something. Is it true? Is it false? Well, of course it's false. 1/2 is greater than 1/5. I know this because if I divide one whole into 5 equal parts, then each of those parts would be smaller than if I divided the same whole into 2 equal parts, or found half of it. We can also prove the concept using a pictorial representation like this one. I've got 2 bars which are the same length, the same size. One of them is being divided in half, one of them divided into fifths, and I can clearly see that 1/2 is greater. Let's take a look at this slightly strange one. Where's the whole, do you think? Is the whole the entire glass? What fraction does each of the images represent? There's this idea here where comparing unit fractions, the bigger the denominator, the smaller the fraction. Now let's take a look at the number line. Do you think the number line matches the images? Why or why not? Well, I mean, if I was thinking about it, my instant reaction would of course be the whole glass should be the whole. So that picture on the right hand side, surely that's half the glass. But why not? Let's say that half a glass of rice represents the whole. So now the picture's in the right place. Is the glass that's suspended there in the middle over the half marker, does that represent half of the whole? What about the other 2 glasses over on the left hand side? Are they in the right place? The importance of moving between concrete, pictorial and abstract representations is that the concrete experience alongside the precise use of mathematical language will go a long way to avoid misconceptions later. Use those physical things, talk about them, speak about them. Is placing these things on this number line just next to each other and then slapping a number line underneath, is that really helping us with developing our mathematical understanding, with exposing the structure of ordering unit fractions? So after you've compared some unit fractions, let's say you've taken a whole and you've divided it into half, and you've divided it into quarter, and you've divided it into 3/4, why not place them on a number line? Get the physical objects and put them on a number line, write the fractions down. What might be between, on this number line, what could fall between 0 and 1/6? There might be all sorts. We can see that as the denominator gets greater, 1/2, 1/3, 1/4, the amount of rice gets smaller. So what could go between 0 and 1/6? Well, maybe 1/10, maybe 1/100th. There's no real upper limit. We could have a millionth. We could have all sorts of different things. This is to reinforce that when the denominator gets larger, the number of parts in the whole increases, and therefore each part itself is smaller. And we can practice this right from early on. Let's take a look at these 2. How many different ways can we compare fractions? So we could look at the numerators, i.e. if the numerators are the same, then the greater the denominator, the smaller the part. If we're comparing numerators with the same numerator, fractions with the same numerator, the bigger denominator, the smaller the fraction. So 3/4 is greater than 3/7. That's because I've still got 3 parts, but in the first example, 3/4, each of those parts is a quarter, is a fourth of the whole. Whereas in the second, I've got 3 of them, but each of them is only a seventh, and 1/7 is smaller than 1/4, so 3/7 is smaller than 3/4. Now we're dealing with the abstract representations of fractions with the same numerator. Children would need a lot of experience working with unit fractions to develop the relationship between quarters and sevenths and tenths and anything else. Then they'd need to be able to place them on a number line. Then we can go into ordering. Place these on a number line, these 2 fractions here on a number line. Where would they go? Explain the position of each one. Let's take a look at it. Here it is. I can think about the relative position. 3/4 is greater than half because half of 4 is 2. So I know that if I had half of it, I would have 2/4. Whereas half of 7 Oh, yeah, that's a bit too tricky for me. But I know that 3 is not half of 7 because 3 is only half of 6. So that's less than a half. But are there misconceptions that could arise? What might someone explain where how could someone explain where 3/7 goes in the number line if you don't know what half of 7 is? Some of these things could cause a problem. Now this instance, we have different denominators. We don't need to create equivalent fractions. We don't need to find common denominators or convert fractions. This is just the core understanding of denominators from our earlier work comparing unit fractions. I know that 1/4 is greater than 1/7, therefore 3/4 will be greater than 3/7. If I had a half of an object and I cut out 3/4 of the same whole and I cut out 3/7 of the same whole, where would they fit on my number line? So I can look at that generalization. When comparing fractions with the same numerator, the bigger the denominator, the smaller the fraction. Let's take a look at these. Now you'll find these lists of fractions in your pack. There are four sets of fractions, 4 lists of fractions. What I want you to do is have a go at ordering them. Order set 1, then order set 2, then order set 3, then order set 4. I want you to think carefully about how you ordered it. What skills did you use, do you think? We're going to talk through the key skills needed for ordering each of these sets, but keep your thoughts together, have a think about them, write some things down. We're going to discuss your reflections the next time we come back together. Okay, so we'll have a look at the answer, if you like, for set 1. Do keep your ideas for what your thoughts were whilst you were ordering those fractions. We will be discussing those. So here's a generalization, a STEM sentence. When comparing fractions with the same denominator, the bigger the numerator, the bigger the value of the fraction. So, for example, 3/8 is less than 5/8. I've got the same denominator. If I've only got 3 of those things, then that's fewer than 5 of those things. So in set 2, we have this. Now there's definitely different denominators going on, but in this one, when comparing unit fractions, and unit fractions, if you don't know, if you haven't figured that out yet, unit fractions have a 1 as the numerator. They are 1 of that particular size piece. The bigger the denominator, the smaller the value of the fraction. For example, 1/2 is greater than 1/3, which is greater than 1/4, which is greater than 1/6, and so on. Let's take a look at set 3. So in this case, again, I've got different denominators, but we've used this generalization before. When comparing fractions with the same numerator, the bigger the denominator, the smaller the value of the fraction. For example, here's 3/8, and in the same bar I can represent 3/5, which is greater. So the numerator is the same, therefore the greater the denominator, for example the 8ths, the smaller the value, the smaller the amount of the fraction. And let's take a look at set 4. Now, take a stop, take a think. What do you notice? Can you apply some fractions knowledge to this? How about noticing that they're all just 1 piece less than the whole? 6/7 is 1 less than 7/7, which is a whole. 11/12 is 1/12 less than a whole. 4/5 is 1 less than 5/5, which is the whole, and so on. They're all just 1 piece less than a whole. And when comparing unit fractions, the bigger the denominator, the smaller the value of the fraction. So if I can consider the size of the unit fractions which are left to make the whole, that can still help me to order those pieces. We'll have a look at what the correct answers were in the end, and I'd love to hear your thoughts whilst you were doing it when we next meet live. Okay, so let's have a look at solving a problem in lots of different ways and comparing those different ways. Now this is really, really essential. Lots of different methodologies. Ask all the children, do you have a different way? Did you do it differently? If the answer is only the beginning, give them the answer to start with and explore the different methodologies. Consider what different ways you could do to share, you could solve this problem so that we can share some ideas next time. So we're looking at to show that 3/4 is less than 4/5. Can you find 3 different ways? Can you find more? Make a note of some different ways you've managed to do this for next time. Okay, now we're going to have a really quick look at bar modelling. bar modelling with fractions. We've already seen quite a lot of this throughout the 3 sessions. In this case, we're just going to look at a few examples of how we might feed bar modelling into some problems and lessons in Key Stage 2. Remember, bar modelling is just one representation that we can use to expose the structure of a fraction. It's only one, but we're going to focus on that one. We've done lots of bar modelling in terms of exploring what a fraction is, the part-whole relationship, which really supports the Key Stage 1 work. So this is a little bit of a step forwards, but also Key Stage 1 teachers. Remember, well, firstly, one day you might end up in Key Stage 2, so it's good to know. But also, this is the basis of their learning. You're not just learning to achieve the objectives in your year group, nor are any others, but you're looking to support the foundations, to build the foundations for the next year groups. It's really important we all have a good understanding. Okay, so here's the idea of fractions of amount. So I'm being asked for 1/3 of 18. I've drawn a bar model, I've divided it into 3 equal pieces because it's asking me for thirds. I've represented the whole of the bar model as 18. Now I'm thinking I need to divide 18 by 3. That will give me 6. And that tells me that each of the thirds is 6. So I can repeat that, I can iterate that 6. Remember that idea of iteration, 1/3 add 1/3 add 1/3. So 6 add 6 add 6 equals my whole. Now of course I'm being asked for 1/3. So 1/3 is 6. 1/3 of 18 equals 6. Straightforward, yeah? Let's take a look at this example. What's the same and what's different about it before we start? Oh, the whole is still represented by 18. Good, that's the same. What else is the same? Oh, we're still working in thirds. It's still got 3 equal parts in a bar. Any differences? We're looking for 2/3 this time. Well done. Okay, what's the same and what's different? We've identified those things so we can use that. Let's think about what we did to start off with last time. My whole is 18, so it's divided into 3 equal parts, so let's do 18 divided by 3 equals 6. That means that each of my parts equals 6. Let's double check that. 6 add 6 add 6, let's count in sixes. 6, 12, 18. Great. Now, slightly different, I'm now looking for 2/3. So 2/3 is 12, it's 2 of those parts together. 2/3 of 18 equals 12. I wonder if anybody's made use of anything like this before. You could use this actually for number bonds of 10 or 20, helping to build up the fact family idea, maybe in your basic skills lessons and in those sorts of activities. Now, in this question, the fact family being shown, we've got 1/7 here, 1 out of 7 pieces in blue, 3 out of 7 pieces in green, 4 out of 7 pieces all together. Let's look at that as fact families. Here's the first one. Got my 1/7 and my 3/7, and altogether that's 4/7. And of course we can then build up the other fact families as well, just by moving the parts around. We could explore the commutative nature of the addition. So 1/7 and 3/7 is the same as 3/7 and 1/7. And equally that we can't do that with subtraction, that we start with the whole thing that we're subtracting from in subtraction. Take a look at this one. How can we extend this activity into some independence? How many different calculations could you write to describe the bar models here? So of course in that first one we could say 1/5 plus 2/5 equals 3/5. 2/5 plus 1/5 equals, 2/5 plus 1/5 equals 3/5. Maybe 3/5 minus 1/5 equals 2/5. 3/5 minus 2/5 equals 1/5. Maybe you could even say 5/5 minus 2/5 minus 2/5 minus 1/5 equals 0. You could even go that far. You could look at lots of different ways to describe these different bar models. So that's the end of the sessions. I just want to finish off with one final reminder of these 5 big ideas. These are utterly essential: representation and structure. Yeah, really use those representations to expose the structure of the mathematics to help them to understand what's happening and make connections between those groups. In the mathematical thinking, make sure you've got reasoning conversations, reasoning questions throughout your input. It's more important to have reasoning discussions throughout your maths lesson than it is to stick a reasoning question at the end of the task. Your fluency. Vital. We should be doing at least 3 sessions a day of our basic skills program. We're looking at number facts, table facts, making connections between those facts, and really having that fluency to then be able to input to other areas. And notice that's not just fluency in terms of fluency, problem solving and reasoning. It's not just fluency of concept, but fluency of number. And the variation. Do you have conceptual variation showing a specific pictorial representation, maybe showing a different way of looking at the same thing? Do you have procedural variation where you're taking a sensible small step journey, changing just one thing at a time to build up the understanding? And are you bringing all of those things together in coherent mathematical lessons, small step approaches to work slowly through a process, developing all of that deep understanding? That's what mastery is. I'd like to thank you for watching all of these videos. We will of course do a final live session at some stage as soon as we're possibly able to, where we'll discuss some of those thinking phases and also some of the other ideas that you might have come across and other concepts that you might have come across during these sessions. Okay, I would like to thank Sam for his support from West Yorkshire Maths Hub, and of course the National Centre for Excellence in the Teaching of Mathematics as well for all their resources used in these sessions.